Hello. In today's video, we are going to discuss on the mysteries of the indexing. Indexing is a crucial and often overlooked cornerstone of databases, performance, and the scalability. Whether you are a developer or a database administrator or just a techie, understanding indexing can be significantly lift your data handling game. Let's decode the magic behind the indexing, explore its type, and master its challenges together. Okay. So first thing is let's discuss about the concept of the indexing. I will give you an example. So now imagine navigating a city without a map or direction. So that's your database sourcing through millions of data points without an indexing. So indexing is a map for a database and it guides it to the exact data you need without wandering through the irrelevant information. So for example, there is a book. Okay, so in book you have indexes, which page you need to go and where you will find your relevant information. So you see in the indexes and then you navigate to the page. Same is the concept in the databases as well, or wherever you go in the searches, or it is in a database platform, or it is in Google Maps as well. So indexing plays a vital role for getting a seamless user experience or get the required information for the user. Indexes are not just about the speed. They're about the efficiency as well. It's something like we create a structured pathway to the data, and indexes reduce these input and output operations and slashing the query execution time and conserving the resources. This leads not just to the faster application but also lowers the cost and improved user experiences. So every time a user is going to hit on to the actual content, imagine like if you have thousands or millions of requests at one time, the database performance will get slowed down. So if we have the indexes in place, it can segregate the information. This user needs this certain information. So let's navigate. Let's also discuss about one real world example. Let's discuss about the Spotify. So as you know, the Spotify is a vast music library. There, indexing basically helps the users to find the favorite song in milliseconds out of millions. So if we don't have indexing there, so searching would feel like flipping through the global book for a single number. So a user can simply go and find its music. This thing happens because of the indexing. So whenever you go to Amazon Prime or Netflix or Spotify, any application, even in the Google as well, so you can simply search it, and not only search it, basically how you are able to search it fast. Okay, so it improves your efficiency, it lowers your cost, and also enhances your user experiences as well. So now let's talk about the challenges. So while indexing accelerates the data retrieval, they come with their own baggage. Okay, increased storage requirements, higher maintenance overhead, and potentially lower write operations as well. So it's in a balance act between the read efficiency and the write performance. Imagine adding more and more indexes to a database. It's adding extra weight to a race cars. Initially, it makes navigating faster around the corners, but too much weight slows down the overall speed as well. So this requires good, system design, good architecture in place, where this is not, adding an overhead to the databases, how you can scale it, or how it can, scale down as per the user request or the data which is getting ingested or indexed into your databases or whatever it is, whatever the storage you have. So it requires a proper designing strategy, architecting strategies. If we design properly, we are good, but if we are not designing it properly and we are keep on dumping data onto the storage or the databases, it can also impact your system performance and the efficiency of the user experience. So now let's discuss about the spectrum of the indexes. Spectrum, I mean to say like flavors, okay, or the types of the indexes. Each index serves a unique purpose. So for example, we have a primary key index. Okay, so this is a basically backbone of data integrity, which basically ensures that each record is unique. On the other side, we have a foreign key index. Okay, this is the second one. This basically cements a relationship between the tables, and it is also crucial for your referential integrity between your tables and the data. The third one is the cluster indexes. It basically helps you in organizing your library. They basically sort out the actual data in a specific order as per the user needs. We'll discuss about all various flavors of indexes in a separate video because it will require time and a lot of concepts which I want to talk about in upcoming videos. But I will be quickly walking you through what are the different types of indexes and what is the purpose of these indexes. Then is the composite indexes. Basically, it combines the multiple columns under a single index. Okay, so it is basically used for the complex queries. So if the user wants to search more than one single query, they need to do a complex search. They want to find when this guy was born, at what place, what time, okay, what was his life, what was his career journey, okay, did he went in some war, whatever it is. So it requires a complex query. Definitely, this kind of composite indexes are used in the research, right? In the healthcare, in the financial, in the e-commerce. So in the research part, this kind of indexes are used. Moving to the next one is the partial indexes. So partial indexes, think about it as you focus on a subset of a data, and this is perfect for the scenarios where only only a fraction of the data meets the query criteria regularly. It only performs a certain action or provides you certain information about data when this query criteria meets. So then is the functional indexes. Functional indexes are based on the expression. They transform the data before indexing, and basically it helps us in the complex data retrieval. Then comes the full text indexes. So full text indexes are basically specialized for the text heavy data, and this enables the efficient search throughout the documents or the descriptions. Let's talk about some example. So let's put this into perspective with a blogging platform. To quickly find a post by date, a cluster index on the post column ensures the data is physically stored in chronological order or searches by the title and the content, right? And all these things happen very rapidly. So using the above indexing strategies or indexing flavors, the user is able to find the information or query the data efficiently and rapidly. Then let's discuss about how we can design an optimal indexing strategy. The first thing is like it requires strategic planning. Then in the strategic planning, it is something right like designing the perfect index strategy, which also involves like understanding your data access patterns. Okay, you also need to analyze the query logs and to identify frequent access paths, and also you need to balance this against the impact on the right operations as well. Once you have this information, then it's something like you need to predict the roads which are most traveled and pave them for a speed. So all this information you need some data sets, okay, to design your optimal indexing strategy. Then comes about the tools and techniques. So you have to decide about which tools and the techniques I need to use or the user needs to use, which can explain you about like how can properly place the indexing strategy in place, right? Also you need to impact the assessment as what sort of impact it can have on the system. Impact of indexing, which involves before and after performance analysis. Okay, so there are tools or the commands, right, like the pgstat user index in the Postgres or system db index user stats in SQL Server, which will basically gives you the insights into the index effectiveness, and also it guides for your optimization efforts as well. There are a lot of such kind of assessments and the techniques which you can go through, but this is not in a small field. It's in a very vast field which you requires so deep understanding about doing the assessment, selecting the right tool, right techniques to make this happen. So now let's talk about index maintenance, which will basically keep your performance high. So just as a car, it needs a regular servicing. If you don't do a regular servicing, it will not give you right mileage. You will be get stuck in some issues related to your engine, related to your steering, brakes, clutches, whatnot. So similarly, indexes also requires the maintenance to prevent the fragmentations, fault or inefficiencies. So you need to set up a routine index rebuilds or reorganization, which will basically ensure your databases engines run smoothly, much like regular oil changes for your vehicle. So similarly, in the indexing world, you need to keep on analyzing the things, the logs, or what sort of operations are happening on your database, which will basically ensure like your database is running smoothly without any flaws and without any issues. Now we'll discuss about what are the advanced considerations about your optimizing your database, which is not only just about adding the indexes, it is also about understanding the data distribution, how the partitioning is done for the large indexes, and even considering the alternative storage models. So remember that the best database is not fast, it is smartly tuned to its workload. There are a lot of databases, right? Like AWS OpenSearch is there, Elasticsearch is there, Kendra is there. Okay, similarly, companies have their own tools. So I'm talking about AWS since I have worked on AWS indexing solutions. So this is not only about like where you store the indexes. It is something about like how you manage them and like what sort of configurations or strategies you apply to on your indexing platforms, which basically enhances the performance of your indexing platforms, right? So indexing is both an art and science, and it's a delicate dance between the speed and storage, efficiency and overhead. But with the right strategy, tools, maintenance, you can elevate your database's performance to new heights. And whether you are managing a small app or a massive application, indexing skill is worth mastering. So I hope you guys find this video insightful, and for more such videos, please hit like button, share this videos with your network, and don't forget to subscribe for more similar kind of tech exploration. And if you have any questions or your topics you want me to cover, drop a comment below. Happy indexing and see you in the next video. Thank you.